Okay, explore number 3. Evidence for plate tectonics. What are the processes thought to drive the motion of tectonic plates? Tectonic plates. Okay, so we've established that they move. Now, how do they move? What's actually causing this movement? Okay, so go ahead and write down what you know or you think. Pause that video for a second there. Make sure you put the normal things here in your notes, the date, the reference, and the essential question. Okay, and we're going to take that first one there, processes that drive plate tectonics, straight from your text. So probably the best place to start is at the core. Okay, you know that it's hot. I think probably a key part that's worth thinking is that you have uneven distribution of thermal energy from Earth's interior. As that energy is radiating up through the core, into the mantle, and into the crust, not everything is transferring that heat at a uniform rate. Okay, and this is what we mean by uneven distribution of thermal energy. Okay, for whatever reasons, anywhere through the thickness of Earth's interior, you can have things that affect the distribution of heat. And so when it gets to Earth's surface or underneath Earth's crust near the surface, we see that some areas might be moving faster, some areas might be moving slower, etc. Okay, so this results, the result of number one, having this heating and then this uneven distribution is we see what's called mantle convection. Okay, and convection is where you have hot materials that rise, cold materials that sink. If you're in the atmosphere, you can have convection cells. Warm air rises, cold air sinks. If you're in the ocean, you can have warm water rise, cold water sinks. So these convection cells or currents, they're a big concept. You should appreciate and understand it by now. So in our core, in our interior of the Earth, we have hot material that rises. We have cooler material that sinks. Has to do with density. And this is a continuous cycle, and this causes movement of tectonic plates. Now remember, the mantle is not liquid. Not like a glass of water, right? It's solid, but it's more like a soft solid. It's like a soft rock, right? Um, if you've ever played with silly putty, putty or clay, it's malleable, it's soft, right? Toothpaste or if you go to the hardware store and you need to get some weather caulking, for the windows or doors, you have those tubes you squirt into that thick, kind of pasty material. That's a good way to think of the mantle. Okay, it does move, but it's more like a solid. Okay, now here's some other ideas you may not necessarily have be aware of, or maybe you forgot. One is called slab pool. When you have convergence of two tectonic plates, um, in this case, we'd be talking about the ocean crust converging with the continental crust. You know that the denser ocean crust is going to subduct. It's going to sink below the continental crust because it's heavier, it's denser, right? It's made of denser materials. And where it sinks, we call those subduction zones, right? So the interesting part about that is that, what did I want to say on that? That leads actually to the next portion, actually. That slab, that oceanic crust is actually sliding downwards from the ridge themselves. Remember, you have seafloor spreading, you have magma pushing up at these mid-ocean rift zones, producing these mid-ocean ridges. Well, the elevation's relatively high there. and that big slab of rock that's being freshly made, um, as you move outwards towards the subduction zones where it starts to sink, the elevation is lower over there. And so it's almost like it slides down there. So not only do you have convection currents going on, not only do you have you have this giant crust that is sliding downwards because of the elevation difference. And here we go back to B, slab pool. As it starts to subduct, the weight of that giant plate, as it gets deeper and deeper into earth, it actually starts to pull the whole slab down. And this is helping to pull or push the tectonic plates around as well. Okay, so there's three processes that you should be kind of comfortable with here. Okay, there's um, the slab pull, there's the ridge push, and then of course you have your convection currents, and that I think takes care of it. So go ahead and let's make sure you write down. I shouldn't have to do this, but I'm going to write this down because some of you that aren't necessarily doing this. Summary paragraph. Okay, make sure you do that. You're in the business of trying to make this stuff stick in your brains. All right, talk to you soon.